Okay. In the previous session, we have discussed Chapter 3, Transportation and Assignment Model. Now we are going to start Chapter 4, that is the decision theory. Therefore, after completing this chapter, we are going to discuss the different decision-making environment, and also you should explain the decision-making under uncertainty with different risks and probabilities with utilities. Therefore, decision tree, which is one of the theory which is available for managers to make one best decision. Therefore, there are different decision variables that managers should consider in order to make one best decision. Therefore, the environments are certain, whereas some environments are uncertain. Therefore, the difference, for example, you can also take into consider the demand for a product may not be 100 units next week, but it may vary. Sometimes it may be 50 to 100 or more than that, depending on the market, which is uncertain. Therefore, sometimes in predicting our revenue or profit margin of the business enterprise, companies may use different kinds and types of decision theories. Therefore, these are the characteristics of the decision theory. Therefore, basically 5 characteristics of this decision theory. The first one is you can list the alternatives. Therefore, this list of alternatives are the mutually exclusive and the collectively exhaustive decisions. And the second characteristic of this decision theory is states of nature. You can set the possible future conditions or events. And in the third characteristic of this decision theory model is it is a payoff. That is, this payoff may be related with profit, revenue, cost, or other measures of value. And the fourth one is the degree of certainty, or that is exactly which is existing. And also the fifth characteristic of a decision theory, which is decision criteria. That is maybe the decision maker attitude towards the decision. Therefore, sometimes the decision attitude of the company may be to maximize profit or to minimize cost. It depends on the insight of the managers. Therefore, these are the these are the 5 basic characteristics of a decision theory. Therefore, in order to make one best decision from the given alternative decisions, first we are going to construct a payoff table. A payoff table is a device that a decision maker can use to summarize and organize information which is particularly important for decision maker. Therefore, it includes a list of alternatives with the possible future states of nature. The payoff associated with each of the alternative or state of nature combinations. Therefore, the general format for the decision theory here is just like a transportation model also. It is the division of the rows and the columns. This is the columns value, which is describing the state of natures, whereas in the row value, which is describing the alternatives available. Therefore, from this table, you can see or you can observe there are 3 states of nature with 3 alternatives available. Then, first, we are going to see the decision making under certainty. All the information are available, or in order for the manager to make decision with all information here, we can use the decision making under certainty, all the information available. Therefore, now the following table displays the 3 states of nature with different values, which is this describing the revenue values, and with these 3 alternatives. Therefore, now under this decision making under certainty, there are 5 basic possible criteria are available. That is the Maxim Ax, Laplace, the Minimax Regret, and the Hurwitz approach. Therefore, the first we can consider is the Maxim Ax approach. Therefore, in a Maxim Ax approach, you can select the maximum value from the maximum payoffs. Therefore, which is an optimistic approach, whereas the Maxim it consists of identifying the worst or the minimum payoff for each alternative, and then selecting the alternative with the highest best or maximum of the worst payoff, which is pessimistic approach. Therefore, for example, in a case of Maxim Ax, you can go from your right hand side to your left. You can choose the maximum value from each row value, and you can choose the maximum. Whereas to apply the maximum approach, you can choose the minimum value from each row value, and you can choose the maximum. And in a Laplace approach, you can take into consideration the average payoff value. Therefore, you can sum the values under each row value, and you can sum and you can take the average best value. Therefore, the Laplace approach treats the state of nature as equally likely, whereas the Minimax regret determines the worst regret for each alternative and choose the alternative with the best worst. And now with this given example, there are three possible feature profit, S1, S2, and S3, with alternatives A1, A2, and A3. And example 1, referring to the payoff table, determine which alternative would be chosen under each of these strategies. Now we can take into consideration the Maxim Ax approach. Therefore, in the first row, from 4, 16, 12, the maximum value is 16. In the second row, 5, 6, 10, the maximum value is 10. In the third row, from -1, 4, and 15, the maximum value is 15. Now, from this displayed maximum row values, you can choose the maximum value, that is 16, which is A1, will be chosen if it is the Maxim Ax. But what if when these values are costs? Therefore, you can choose the other side, the mean approach you can apply here. Therefore, you can choose the minimum value is 4. Here from this, you can find the minimum value is 5. You can find from the third row, the minimum value is negative. From the minimum value, you can choose the minimum value. So therefore, from 4, 5, -1, the minimum value is clearly -1. You can choose A3. Therefore, in the second, the Maxim criteria, you can choose the minimum value. In the first row, the minimum value is 4. In the second row, the minimum value is 5. In the third row, the minimum value is -1. From this minimum value, you can choose the maximum value, which is clearly A2. Our decision is A3. What if when these values are costs? Therefore, you can apply the Minimax criteria. Therefore, the Minimax, that means you can find the maximum value, 16, 10, and 15. From this maximum, the minimum value is 10. Clearly, A2 will be chosen if these values are costs. The other, for the Laplace criteria, you can sum each row values. Therefore, in the first row, 4 plus 16 plus 12, 28. 28 plus 4, 32. 32 divided by 3, it will become 10.67. And this is the second row, 5 plus 6 plus 10, 21. 21 divided by 3, which is clearly 7. And in the third row, you can sum 15 plus 4, 19, 19, minus 1, 18, 18 divided by 3, 6. Therefore, the highest value is already A1. A1 will be chosen. If it is cost, the lowest value, you can choose A3 because it is the minimum value, while summing the rows values and dividing the total state of natures, that is 3 state of natures. The fourth one is the Minimax regret. But to apply this, the Minimax regret, the first step is to prepare a table of opportunity loss, or you can develop a regret table from the original table. Therefore, to find the regret table, you can find the highest value from each column, the highest value. For example, the highest value in the first column is 5. The highest value in the second column is 16. The highest value in the third column is 15. You can deduct this value, 5 minus 4, 1, 5 minus 5, 0, 5 minus 5 minus negative 1, which will become 6. Now, 1, 0, 6. And in the second column, you can find the highest value 16, 16 minus 16, 0, 16 minus 6, 10, 16 minus 4, 12. Therefore, the result will become here 0, 10, 12. In the third column, the highest value, the highest column value is 15. 15 minus 12, 3. 15 minus 10, 5. 15 minus 15, 0. Therefore, 3, 5, 0. 3, 5, 0. Therefore, you can apply this, the minimax regret. Therefore, the minimax in the first row, the minimax, the highest value is 3 from 1, 0, 3. In the second row, the highest value is 10, clearly from 0, 10, 5, 10. In the third row, the highest value from 6, 12, and 0, the highest value is 12. Therefore, in the second step, you can identify the worst value. Therefore, the worst value clearly is the smallest value. That means applying the minimax. Therefore, from the maximum value, you can choose your choice on the minimum value. Therefore, these are the highest value in each row, but the lowest is 3. Therefore, our decision as a manager of an enterprise is A1 is the best and selected. The fifth one is the Hurwitz criteria. This is the Hurwitz criteria strikes, or which is a compromise between the Maxim Ax and the Maxim criteria, which is neither totally optimistic nor totally pessimistic idea. Therefore, in order to apply this Hurwitz criteria, you can consider into a coefficient of optimism. Therefore, the coefficient of optimism, which is defined as by alpha value, is between 0 and 1. 0 less than alpha value less than 1. If alpha is 1, then the decision maker is said to be completely optimistic. If alpha is 0, then the decision maker is completely pessimistic. Therefore, this alpha value is given by, that is the personal judgment, or based on the intuition, or based on his experience. A manager can determine simply the alpha value. Therefore, now we can consider the original table now here. Therefore, based on the manager intuition, the alpha value here is 0.4. Therefore, which would be your decision from A1, A2, and A3. Therefore, here in the first, in this table value, now the alpha value is 0.4. The maximum value you can choose 16, 10, and 15 are the maximum value. The minimum values are 4, 5, and minus 1. Therefore, the given here, the given alpha value, that is 0.4, you can multiply this 0.4 with the maximum value from each row. That is in the first row, 16 in the second row, 10 in the third row, 15. And you can deduct this alpha value from 1 minus alpha. Therefore, clearly 1 minus alpha, that is 1 minus 0.4, which will become 0.6. Therefore, you can multiply this 0.6 with the smallest value from each row. Therefore, in the first row, the smallest value is 4. In the second row, the smallest value is 5. In the third row, the smallest value is 1. Therefore, you can multiply this highest with the alpha value, and the lowest with 1 minus alpha value. Therefore, in the first row, the result will become 8.8. In the second row, the result will become 7. In the third row, the result will become 5.4. Therefore, the decision A1 is selected here because it is the highest value A3. But if it is cost, you can select clearly that is the smallest value A3, that is 5.4. Therefore, the other tool or criteria that we apply here in making a decision is under risk or with probabilities. Therefore, it is often possible for the decision maker to know enough about the future state of nature to assign probabilities to their occurrences. Therefore, here the term risk is we should consider because there is a probability is given. Therefore, there are different techniques that are available. The first one is the EMV, or expected monetary value. The other one is the EOL, the opportunity loss. And the last one is the EVPI. Therefore, let's take the first approach when there is the probability of occurrence of this different revenues with these three different state of nature here stated here, and the three alternatives A1, A2, 3 are here displayed, and with their probability. This is the first state of nature. The occurrence is with probability 20%, whereas the second state with 50%, and the third state with 30%, and the expected payoff. You can find the expected payoff by multiplying this probability with the first row value, that is 4, 0.20 times 4 plus 0.50 plus 16 plus 0.3 times 12, which will become 12.40. You can see also their mathematical result for the expected value for alternative A1, that is multiplying the probability with that is the first row value, the second row, and the third row 12.4, and in the second row it will become 7, and in the third row it will become 6.3. Therefore, you can choose A1 will be chosen based on this expected monetary value. When it is cost, clearly it is the smallest value will be selected. Then here the expected opportunity loss, or EOL. Therefore, here to apply this EOL, you should consider, or you should change this table into an opportunity loss. Therefore, to change an opportunity loss, to change this table to an opportunity loss, you can find the highest value in the first column, which is 5. In the second column, the highest value is 16. In the third column, the highest value is 15. You can deduct this the highest value from each column value and deduct the value. Now the result will become, that is the opportunity loss table. Therefore, you can multiply the opportunity loss values with the probabilities. You can take also this table here, this the minimax regret table. This is opportunity loss table. Ignoring this, the worst result here, ignoring the worst result, you can take into consider this value to an opportunity loss, and you can take into consider their probabilities. Now the result of the expected opportunity loss for A1 will be 1.10, and the row EOL for A2 will be 6.50, and the EOL for A3 will become 7.20. Therefore, you can choose the minimum value, that is 1.10. based on this expected opportunity loss. The other one is the expected value of perfect information, or the EVPI. This expected value of perfect information is a measure of difference between the certain payoffs that could be realized under a condition involving a risk. Therefore, first, to find the EVPI, the formula of EVPI is EPC minus EMV. EPC, which is referring to the expected payoff under certainty. Therefore, the EPC, you can find the highest value from each column, and the highest value from each column. In the first column, the highest value is 5. In the second column, the highest value is 16. In the third column, the highest value is 15. There you can multiply the highest values of each column by the probabilities under each column, and the result will become 13.50. This is the expected payoff under certainty value, that is 13.50. Therefore, to find EVPI, which is EPC minus EMV, therefore EPC, that is 13.50, minus EMV, that is 12.40, which is obtained from here. This is 12.40. You can take this 12.40 here, and you can find 1.10. Therefore, which is a similar result with the expected opportunity loss. Therefore, one can deduce here is that the EVPI exactly equal to EOL. Therefore, the EOL indicates the expected opportunity loss due to imperfect information which is other ways of saying that the expected payoff under perfect information. Therefore, a manager can make a decision with no any information, and also a manager can make a decision by collecting all the available information. This displays here in the two decision theory models available here in the quantitative tools. Therefore, the last one is decision tree. This decision tree is the other way of this. It is similar with EMV, or expected value, expected monetary value. Therefore, a decision tree, to draw a decision tree, for example, if you plant, for example, a mango, you can plant, and the plant will grow, and it will bring some fruits on his branches. Therefore, when the branch is not fruitful, therefore you can cut to make that branch more fruitful. Therefore, we can bring also this issue to here a decision tree model. Therefore, a decision tree model, which is alternative possible consequences. Therefore, this is the decision tree format. This the square which displays the decision points, a square, and the circles represents the chance events, and the lines which is emanating from each circle displays the different states of nature that is available. Therefore, in order to read this decision tree, you can go from right to the left hand side. Therefore, this is the three tools that you can use to find the best decision through this decision tree. Therefore, in solving a decision tree, you can work from the end of the last from the end of the tree back to the start of the tree, calculate the EMV value, and you can choose one highest based on the given objective. Therefore, these are the three basic procedures to draw a decision tree. The first step is draw a decision from left hand side to your right hand side, squares which is representing the decision, whereas circles indicating chance event. And the second step, which is writing the probability of each chance event in parentheses. And in the third step, write out the outcome for each alternative in the right margin. Therefore, the procedure for solving a decision tree is these are the three steps that you should bear in your mind. Therefore, to solve a decision tree, you can work from right to left at each circle representing chance event and compute the expected value. And in the second step, write the EV below each circle and select the alternative with the highest EV value. Therefore, for example, we can take this company which is producing a glass with different courses of action, that is A, which is representing force of contracting, whereas B with probability of constructing new facilities, and C with no change, do nothing or do no change. Therefore, which is showing low, medium, and high. Therefore, the management estimates the respective demand probabilities with 0.1, 0.5, and 0.4. Therefore, now the table here displayed here. Now, these are the three alternatives A, B, C, and with the three states of nature, low, medium, and high, with their probabilities here given, and this values displays the probability of occurrence, showing the revenue maybe. It will depend on, sometimes it may show the cost value. Therefore, in the first step, you can start drawing the three decisions, that is A, B, and C. You can put a square and you can draw line showing the alternatives A, B, and C. And in the second step, add the state of nature with the probability and the payoff. The first decision, there is high demand, medium, low demand, high demand, medium, low demand, high demand, medium, and low demand for each three alternatives available with their probability 0.4, 0.5, 0.1 for each. And with their state of natures, for example, for alternative A, for example, 10, 15, 19, you can bring here 10, 15, 10, not 19, 50, 10 here. In the second alternative, you can bring 225 and minus 120, and you can multiply this probability with this state of nature, and summing the result, you can obtain the value of the AMV for A, and therefore multiplying this probability with 0.5 times 50 plus 0.1 times 10 will become 62. Therefore, you can bring the 62 here, and in the next you can find the value of B, then multiplying the probability with the state of nature, the medium demand with probability here, and the low demand 0.1 with the probability, and finally you can obtain the value 80.5. You can bring this 80.5 here under the AMV value of B, and in the value of C you can multiply 0.4 times 60 plus 0.5 times 40 plus 0.1 times 20, and the result will become 46. You can bring 46 here in the C value, and therefore this is the last step, that is to make a decision. We should concentrate on the AMV value of each alternatives A, B, C, that is 62, 80.5, and 46. Therefore, from this, the highest value is clearly, that is 80.5, which is alternative B. Therefore, the manager can decide on B to generate the highest expected profit. Therefore, that is constructing any facility will bring profit to the business enterprise. If it is cost, you can choose the smallest value, that is 46. Therefore, C is making no change here. Therefore, this is our today's discussion, or which is the end of chapter 5. In the next session, we will meet with the last topic, that is the network model, next time. Thank you very much for your stay. See you next time. Bye.